In this video, I'm going to show you how to use a 30, 60, 90 triangle to compute the values of the trig functions at 30 and 60 degrees. So first of all, why don't we draw out this 30, 60, 90 triangle? We've got a template of an equilateral triangle, and remember an equilateral triangle has all angles 60 degrees, so this will be where our 60 degree angle is. And now we want to introduce a 30 and 90 degree angle. So what we can do here is we can just drop an altitude of the triangle here. It'll be perpendicular to the base here, and that'll make our 90 degree angle. And then this altitude will bisect the top angle, so this will just be 30 degrees, and there we go. There's our 30, 60, 90 triangle. So why don't we just fill in the sides nice and green here. Okay, great. Okay, so why don't we assign some values to the sides here? Why don't we call the shortest side of this 30, 60, 90 triangle, why don't we call that 1? And then, since this shortest side is half of a full side of the equilateral triangle here, then the longest side is going to be the full length of that equilateral triangle side. So we just need to double this whole length here would be 2, so that'll be the length of our hypotenuse here, because that's a full side of the equilateral triangle. And then we need to solve for what is the remaining side. Let's call this B. So we know two of the sides, 1 and B, and we know the hypotenuse. Well, how can we solve for B? We can just use the Pythagorean theorem. So let's go ahead and do that. So Pythagorean theorem says that the hypotenuse squared, 2 squared, is equal to the side 1 squared plus the other side B squared, and we can solve for B that way. So 4 equals 1 plus B squared, 3 equals B squared, and then root of 3 is equal to B. Positive root of 3 because we want a physical quantity here. So B equals root 3. And here we go. We've got our side lengths here. We've got 1, root 3, and 2. All right, now we're ready to compute some of these trig values. Let's look at the 30 degree ones first. So looking at this angle here, 30 degrees, let's write down sine. What is sine of 30 degrees? Well, we can just use SOHCAHTOA. SOHCAHTOA says that sine is just opposite over hypotenuse. So opposite over hypotenuse, and that's going to be equal to, well, opposite side is 1, and then hypotenuse is 2. So sine of 30 degrees is just 1/2. Okay, now we can continue on with cosine of 30 degrees. Same idea here. Cosine of 30 degrees, according to SOHCAHTOA, it's adjacent over hypotenuse. Adjacent is root 3. Sorry, adjacent over hypotenuse. Adjacent is root 3, and hypotenuse is 2 again. So there we go. Cosine of 30 degrees is root 3 over 2. And lastly, for 30 degrees, we have tangent. Tangent of 30 degrees. Well, tangent is just opposite over adjacent. So we're looking at our triangle, opposite is 1, and then adjacent is root 3, 1 over root 3. We can simplify this a bit, times root 3 over root 3 to rationalize that denominator, and we just get root 3 over 3. So there we go. Tangent of 30 degrees is root 3 over 3. Now we can do the same thing for 60 degrees. That's this other angle here. So sine of 60 degrees, that's going to be equal to opposite over hypotenuse, but for this angle 60 degrees. So now it's root 3 is the opposite one. So root 3, and then hypotenuse is 2. And then cosine of 60 degrees is just adjacent over hypotenuse. Now the adjacent side is 1, and hypotenuse still 2. So cos 60 is 1/2. And then tangent of 60 degrees is just equal to opposite, so root 3 over adjacent, which is 1, root 3 over 1, which is just root 3. So there we go. There's our sine, cosine, tangent for 60 degrees, and there we go. We've got them all. We've got all 6 values of the trig functions. All right, here is another example. without using a calculator, we want to compute 3 sine of 30 degrees plus tangent squared of 60 degrees minus cosine of 30 degrees. And thankfully, we already worked out sine, cosine, and tangent for 30 degrees and 60 degrees in the previous slide. So this is going to be pretty straightforward. We're just going to have to substitute these values that we already worked out. We're going to substitute that in the expression. But first of all, let's go ahead and rewrite the expression more explicitly with that tangent squared. Remember, tangent squared just means the squared of the tangent function. So that'll become tangent of 60 degrees, that whole quantity squared. And then in front we have 3 sine of 30 degrees, and then plus that tangent of 60 degrees, that quantity squared, and then minus cosine of 30 degrees. And now we're ready to plug in stuff. So 3 times, what is sine of 30 degrees? Well, looking at our table, we already find out that's just a half. So 3 times a half, then plus, what is tangent of 60 degrees? Well, looking at our table, here it is, tangent of 60 degrees is root 3, so plus root 3, that squared, and then minus cosine of 30 degrees. What's cosine of 30 degrees? Well, it's right here. Cosine of 30 degrees is root 3 over 2. And now we can just go ahead and simplify this. So 3 times a half, that's just 3 halves. Then plus root 3 squared. Well, the squared just cancel out the root, and then we just have plus 3. And then minus root 3 over 2. So let's go ahead and add this. So this is 3 halves plus, let's change this to out of 2. So interpret this as a fraction, 3 over 1, multiply top and bottom by 2, get 6 over 2, and then minus root 3 over 2. And then adding all of this up, we've just got 3 plus 6, that's 9, and then minus root 3 over 2. So there we go. There's our result. All right, here is another example. We want to find the missing lengths A and B in this 30, 60, 90 triangle below without using a calculator. Okay, so let's see if we can use our trig functions to help us here. Why don't we focus on this 30-degree angle? Okay, so can we use some trig functions at 30 degrees to set up some equations that we can solve for A and B? Why don't we focus on A first? So what can we relate A to? Well, we don't want to relate A and B because then we'll have 2 variables in a single equation and we won't be able to solve. But how about we relate A to 10? What trig ratio will relate A to 10? Well, A is the opposite side and 10 is the hypotenuse. OH, that's so sine of 30 degrees. So let's write that down. So sine of 30 degrees is equal to, in this triangle, we have A over 10. And we already know what sine of 30 degrees, it's always just 1/2. So a half is equal to A over 10, and then we can solve for A by just multiplying both sides by 10. So a half times 10 equals A, then a half of 10 is just 5. So 5 equals A. A is just 5. There we go. Cool. Okay, that worked out pretty well. So why don't we see if we can do a similar thing for side B? So side B, how about we try to relate B and 10? This time B is adjacent side here. What pairs adjacent with hypotenuse? So CA. C-A-H, that's cosine. So cosine 30 is what we should use in our equation. Cosine of 30 degrees here, that's equal to adjacent over hypotenuse, so B over 10. And cosine 30 degrees, we already know that's just root 3 over 2. So root 3 over 2 has to equal B over 10. And again, we can just multiply. Root 3 over 2 times 10 is equal to B. And now we just simplify a bit. So 10 cancels with that 2, becomes a 5. So 5 root 3 is what B is. So there we go. B is just 5 root 3. All right, lastly, let's do a little recap of what we've learned. So we figured out what the trig functions evaluate to at each of these angles, 30, 45, and 60 degrees. And let's just look at all our results and see if we can find any patterns that we can leverage to remember this better. So first of all, looking at sine here, notice that sine, the denominators here are all 2. And sine just kind of counts up, going from 30 to 45 to 60 degrees. It's 1 over 2, then root 2 over 2, then root 3 over 2. You could even think of this as like root 1 over 2, because root 1 is just 1. So the numerator just counts up under the root, and the denominator stays the same. It's always 2. And now look at cosine. Cosine just counts down. Instead of going 1 root 2 root 3 all over 2, it goes root 3 root 2 root 1 all over 2. So cosine is just sine but reversed, going from high to low instead of low to high. Okay, so sine and cosine, those are not too bad to remember. And then how about tangent? Do we see any patterns in tangent? So tangent is a little bit different. You might notice that it has a bunch of 3s and a 1, so there's no 2s in tangent. For 30, 45, and 60 degrees, it goes root 3 over 3, then 1, then just root 3. If you ever forget tangent though, remember you can always get it by just taking the ratio of sine to cosine. Say you forgot what tangent of 30 degrees is, then you could remember, well, sine of 30 degrees is a half, and cosine of 30 degrees is root 3 over 2, so tangent of 30 degrees would be sine of 30 degrees over cosine of 30 degrees. Sine, we said, was just 1/2, and then cosine was just root 3 over 2. If you multiply top and bottom by 2, then you get 1 over root 3, then rationalize that times root 3 times root 3, and you get just root 3 over 3, and that matches up with what we've got there. Then it's pretty easy to remember tangent of 45 degrees is 1, because just sine and cosine have the same value. Root 2 over 2 divided by root 2 over 2 is just 1. And then tangent of 60 degrees, you can do a similar thing here. It'll be flipped around though. Instead of 1/2 over root 3 over 2, it'll be root 3 over 2 over 1/2, and that's where you'll just get the regular root 3. Great, so now we know the exact values of the trig functions for 30, 45, and 60 degrees. In the future, we'll also learn how to find the exact values of the trig functions for other special angles, such as 90 degrees and 0 degrees.